Hello, I'm Mr. Parker and this is question 5 on the OCR Core 2 paper from June 2010. For more questions on this exam paper, click the link here or check in the video description. Question 5. The diagram shows two congruent or congruent triangles BCD and BAE, where ABC is a straight line. In triangle BCD, BD is 8 cm, CD is 11 cm, and angle CBD is 65 degrees. The points E and D are joined by an arc of a circle with centre B and radius 8. In part 1, we need to find angle BCD. So this is quite a wordy question, but it's not really saying much for part 1 other than find angle BCD. So going from B to C to D, that means we're trying to find this angle here, which I'll label theta. So what I'm going to do, I'm just going to quickly redraw this triangle. So we've got B, C, D, with BD being 8 cm and CD being 11 cm, and the angle here being 65 degrees. We'll call the angle we want to find theta. And with this triangle, we have two sides that we know, and it involves two angles, one of which we don't know. In any problem involving two sides and two angles, you usually want to be using the sine rule. And the sine rule says that sine A over A equals sine B over B. You can, if you want, write it the other way around. You can write A over sine A equals B over sine B. Both of these are equally valid. I'm going to use this version because the angle I want to find will be on the top of the fraction and it'll be easier to manipulate. So I'm going to label my sides. This side as side A, and this is angle A. The 11 cm side as side B, and the 65 degrees as angle B. So I'm going to get sine of theta divided by 8 equals sine of 65 degrees divided by 11. All I've got to do to get sine theta on its own is multiply both sides by 8. That'll get rid of it on the divide here, but it'll appear up here on the right. So I get sine theta equals 8 sine 65 divided by 11. First of all, make sure your calculator is in degrees. And that gives me 0.659 and so on. So to get theta, I need to do inverse sine of 0.659. Make sure you use the answer button on your calculator rather than typing in 0.659 to get an accurate answer. And I get 41.2 to 3 significant figures. In part 2a, it says show that angle EBD is 0.873 radians, correct to 3 significant figures. Angle EBD is this angle here. We'll call that theta. And in order to answer this question, you need to remember that the two triangles are congruent. That means this angle here is also going to be 65 degrees. So I've got a straight line angle here. 65 plus 65 is 130, and if I subtract that from 180, I get 50 degrees. However, I need to turn that into radians. The rule for turning an angle in degrees into an angle in radians is that I take the angle in degrees and multiply it by pi over 180. And if I do that, I get 0.873 to 3 significant figures. It's also worth noting that most calculators have a way to convert between degrees and radians. For example, on this calculator, if I put 50 in and press equals, and then press the second function and the DRG key here, it will turn it into radians for me, and I get the same answer as before. So that's a good way to check your answer. You should still know this conversion here, 50 times pi over 180, but to check your answer you can always use your calculator. Because I've read ahead in this question, I know that I'm going to need this answer again. So the last thing I'm going to do in this part of the question is store this answer here in my calculator. I'm going to do that using the store button here, which says STO. So I'm going to press that, and then I'm going to press this key here, which has a little green A above it, and that has stored this answer under a variable called A. So you don't have to write this down, but I'm going to write it here just so we remember which one is which. Just in case you're using a Casio calculator, I'll show you how to do the same thing on that. The store button here is in yellow writing above the RCL button, so to get that I need to press shift and then store, and then I can just press my letter after that. So I press A on this one as well, and here look, it says answer has gone to A. So on both calculators I've got here, it stored that as A. In part B, it says hence find the area of the shaded segment bounded by the chord ED and the arc ED, giving your answer correct to 3 significant figures. So I'm trying to find the shaded area up here. I'm going to start by finding the area of the whole sector. And the formula for that is half r squared theta. That one's not in the formula book, it's one you need to memorise. So in this case, I'm going to do a half multiplied by 8 squared, because the radius is 8, multiplied by 0.873. But remember, I've stored that answer in my calculator so I can get an exact value for this part of the question. So in order to get the stored value, it's stored under the green letter A, so I'm going to press the alpha key and then A. Shows up as an A on here, and if I do that, I get 27.9 and so on. Later on in the question, I'm going to use this answer again to find out the shaded area up here, so I'm going to store this answer using a different letter. So I press store, and I'm going to store this as B. And you can see here it says answer with an arrow to B. Just for completeness, I'll show you how to do the same thing on the Casio calculator. So to access the answer stored as A on this one, I press the alpha button, which gets me the red values, and then I press A here, and I would get 80 over 9 pi, exactly the same as last time, 27.9. Next, I'm going to find the area of this triangle made by BED. And to find that, I'm going to do half AB sine C. That's another formula that you need to remember that's not in the formula book. Okay, in this case, for my triangle, this has got to be angle C, which I've already found out. So A and B will be these two sides here, both of which are a radius, so they're 8 centimetres. So I get a half times 8 sine 0.873. Now you may have been thinking earlier when I did this part, why didn't you just use the answer button in your calculator? Because that would have been the last calculation, and I could have done that quite easily to get this answer here. However, now, because the most recent answer in my calculator is this 27.9, I couldn't use the answer button for this, but because I've stored it as a value in my calculator, I can easily access it. Once again, to access a stored value, I press the alpha key and then the variable I'm interested in this case A. And if I do that, I get 24.5 and so on. One last time, I'll store that as a new value. This time I'm going to store this one as C. So finally, to find the shaded area, I need to do the area of the sector, which is 27.9 and so on, and subtract the area of this triangle. So I'm going to use the stored values on my calculator to help with this. So the area of the sector I stored as B, and the area of the triangle I stored as C. So I'm going to do B take away C, and I get 3.41 to 3 significant figures. Now you don't have to use the stored values feature on your calculator, but it does really help with questions like this when you're going back and using values that weren't the previous calculation that you did.